Next chapter is water electrolyte balance. Page number 210. Is it the same page number in new edition as well? Okay, same page. Starting with the chapter, water electrolyte balance. So 70% of our body is made up of water. Some sources may say 75, some may say 60, 65, 70, but understand this part, a majority of your body tissues and cells, water is a major component. Okay, it's not present in the form of H2O. Okay, majority of your body is made up of water. It means it's not that you are made up of H2O. The components of a hydrogen with the different combinations. Okay, different combinations of electrolytes dissolved in that. Combinations of electrolytes dissolved in that water is also present in your body. Okay. So total water body percentage around 60% or 70%. Majority of this water content is found in the intracellular fluids within the cells. Okay, fluid with, again, as I repeating the statement, fluid which is present within the cell, it is not in the form of water that you see outside. Okay, the chemical formula of water H2O that you see outside, it is not in the same way. It is mixed with other components as well. Okay, and 33% of it is found in extracellular fluid. What are intracellular fluid? Which is a fluid which is found inside every cells in the body and tissues of the body, like blood cells, bone cells, muscle cells, adipose cells. These all cells, inside them, water content is present. Okay. Extracellular fluid, again, blood plasma is an extracellular fluid. Blood is a fluid connective tissue. Okay, and 8% of the water content of your body is found in the blood plasma. Okay, blood plasma is the matrix, and the cells, RBCs, WBCs, platelets, etc. Okay, these are the other components of the blood has two major components, the plasma component and the blood cells. Okay, so blood, 8% of the fluid is found in blood plasma. 25% of the fluid is found in the interstitial fluid. Interstitial fluid means the fluid between the cells. Okay, like the fluid that you find inside your stomach, mucus, and the fluid that you find inside the small intestine. CSF, cerebrospinal fluid, the fluid that surrounds your brain, your spinal cord, etc. Okay, so these are the different types of, and more. Okay, these are different types of interstitial fluids found inside the body. So intracellular fluid, we have discussed, fluid which is found inside the cell. Through with this diagram, it is much more easier for you to understand. Extracellular fluid, it means ECF, extracellular fluid. Between two cells, you can see two cells, and between them there are different forms of extracellular fluid. One is what we discussed in as plasma, which is found inside the blood vessels, circulating inside the blood vessels in the form of blood. Okay, plasma is also an extracellular fluid. Okay, it is the fluid that is present outside the cells. Okay, if you imagine blood has these cellular components, but plasma is found, plasma is something that is carrying all the blood cells. Okay, then interstitial fluid, you can see here between two cells, whatever fluid you find here, that becomes the interstitial fluid. Fluid in the dense connective tissue. Can you give an example of dense connective tissue? People who are from the medical background. Any examples of dense connective tissue? Am I audible? Is my voice clear? Your cartilage, bones, cartilage, bones. Okay, they all are dense connective tissue. Okay, as I mentioned, blood is a fluid connective tissue. Blood is a fluid connective tissue. It is liquid in form. It is fluid in form. Okay. Dense connective tissue, it's your tendons and ligaments can also come under this category. Cartilage, bones, okay, they are the examples of dense connective tissue. And transcellular fluid means the fluid that is made somewhere, but it is secreted from that source and it has to go to some other place. For example, saliva. Saliva is made from your salivary glands, okay, but it is taken down into the mouth. Hormones, okay, hormones are made in certain glands, but it is taken out in the fluid form. It is released inside your blood, okay, and the blood will carry the hormones further to other wherever it has its purpose to attend. Okay, so that is transcellular fluid that are in motion. It is created somewhere and it is taken to some other place. That is transcellular fluid. Okay, so is it clear about the distribution of water within your body? Water and electrolytes within the body? So coming to the functions of water, it's a part of the structure. It means the cells, what will happen to the cells if you remove the fluid within it? What will happen to a cell if you remove the fluid part from inside? If you take away the fluid part from the cells, what will happen to the cells? It will collapse. The structure will collapse. There will be no, it will definitely die off. It will undergo necrosis. It will just undergo death. Okay, cell death will take place because without, there is no structure. There is nothing. It will just, cells will just collapse. Okay, so definitely water gives structure to the cells. It will give structure to the tissues, organs. Okay, because cells are the structural and functional unit of any part of your body. Okay, if they lose water, definitely the structure will be also lost. Okay, so that is one function of water. It gives structure. It provides turgor. Okay, turgor means fullness. You see a person who is well hydrated and you see a person who is dehydrated. What is the major difference that you see in these two people? A person who is well hydrated and a person who is dehydrated. Appearance, there is no fullness in the appearance. The person who is dehydrated, that person will not have the fullness in their appearance. Okay, the glow, the fullness will not be there. It will be shrunken. The skin will be quite wrinkly, dry, shrunken. Okay, so water provides turgor. It gives that fullness wherever it is present. Water provides turgor. It gives the fullness. It acts as a solvent. We all know that water is considered as a universal solvent. Specifically, when it comes to electrolytes have to dissolve in water. That's the major principle of the electrolytes existence. Water as a reactant. It participates in variety of different reactions within your body at enzymatic levels, at cellular levels as well. Water is required to be a catalyst or to be a major source of reactant to various chemical activities taking place in your body, enzymatic activities that is taking place in your body. Lubricant, As we know, so for example, take saliva. Majority of the saliva, that if you see the composition of saliva, 99% of saliva is made up of water. Just major 2% or 0.1% is the enzyme salivary amylase and other electrolytes. Okay, so it's a good lubricant. It lubricates the area, surrounding area, wherever it is present. For example, the synovial fluid, which you find in the joints. Okay, a major chunk of it is just water, cerebrospinal fluid, which you find in your surrounding your brain and the spinal cord. Majority of it is water. Okay, so it acts as a good lubricant. It regulates the body temperature in terms of, for example, if you're working out, you are out in the sun, out and about in the sun, working out. Okay, heavy physical activity is going on. You sweat. That is, water is coming out through your skin, and the sweat get evaporated. So your body temperature is regulated. Your body internally is heated up, but because of this perspiration, you cool down. Okay, so that is one example of how water regulates your body temperature. And water is a good conductor of heat and electricity. Okay, water is a good conductor of heat and electricity, so it will keep the body warm as well. If you are well hydrated, your body can stay warm as well. People who are dehydrated will have much more chillness and coldness in their temperature, in their body temperature. Then we have dietary minerals. Water contains significant amounts of fresh water, contains significant amount of minerals. Can you name few minerals which are quite important to be present in the drinking water? Mineral that is supposed to be present in the drinking water. Specifically for your oral health. Yes, exactly. It is fluoride. Okay. Water also supplies dietary minerals based on the source of it. Based on the water source, dietary minerals can be supplied through water, naturally through water. Other functions, water helps the mineralization of organic components within the body. It's also an effective solvent, because of which lots of minerals and other chemicals can dissolve easily and form new reactions in the body. So these are the functions of water. Is it clear to all? So how much water you actually need on a daily basis? You can take a screenshot of this particular slide as well. It will be helpful later. So body weight is given in terms of kilograms. Okay. And the amount of water that you have to consume is given in terms of liters. So wherever your body weight is, this is generalized. Okay. If you're a healthy individual, you can follow this generalized statement. But if you suffer from any other disorders, any other systemic disorders, you have to consult your physician or your consultant based on what kind of water input you should keep on. For specifically when it comes to kidney patients and nephrology patients, water intake is carefully judged. Okay, so based on your body weight, corresponding water intake is also mentioned in terms of liters. Next is sources. So the best source of water first is your drinking water, tap water, distillery, filter water, whatever is your mode of having water, boiled water. So the best source is drinking water. And other sources are foods and beverages, specifically liquid foods like, or clear foods like soup, okay, any curries, okay, tea, caffeine, they are also a good source of water, okay, foods and beverages. Then we have metabolic water. So metabolic water is, you can see here, metabolic water is the water that you have received from food. It has undergone metabolism, food has undergone metabolism, and certain chemical reaction that takes place in your body when water is the byproduct of that reaction. Okay, hydrogen molecules, oxygen molecules could be used, okay, have been used from the water, but the remainder of it, some byproduct have been made, but water was also a byproduct of this particular reaction. So that is metabolic water. Okay. Specifically, when it comes to the end product of combustion or of when carbohydrate, fats, and proteins are being utilized, water usually is a byproduct of such kind of combustions. So fluids, how they enter in through your diet, through your drinking water habits, metabolic water, etc., through which the fluid is present in the body, water from food, metabolic water, and then next how it is lost through feces, sweat, and urine. Urine is the major source through which excess weight will be lost from the body. Then we have water balance. In this particular chapter of water and electrolytes, again, repetition of sodium, potassium, and chloride is there in the textbook, but we have just now covered it recently, entire separately we have covered. We don't have to repeat it again. Okay. So water balance can be achieved in two ways. Okay, one is the way how you intake your fluid. Okay, and how the thirst mechanism and your fluid loss from the body is tackling the water intake. So first is your thirst mechanism. So that is here your central nervous system is also involved. If your thirst mechanism got affected by any head injury, okay, any accident or any traumatic experience which led to your the part of the brain that is supposed to control the thirst mechanism, definitely the person's thirst effect will be affected. Okay, for example, they will not feel thirsty at all. Even if the body is severely dehydrated, they will not feel thirsty. So when your body goes into a state of dehydration, you're running around, you're doing a lot of physical activities, your body is undergoing a state of dehydration. The cells that are present at the back of your throat, okay, back of your tongue, back of your throat, they become dehydrated. And as soon as these cells become dehydrated, the osmoreceptors and the sensory sensors which are present in the mouth region and the pharynx region, that is the back of your throat, okay, they will respond to the dryness that is happening in the mouth and pharynx. So that's how they will send the signal that this person is getting dehydrated. This person should be thirsty now, so that they can stop and drink water. So that is how thirst mechanism works. Then through kidneys, again, internal circulation of salts takes place. Is a process in which majority of the extracellular fluid can enter the lumen of the GI tract, and again it can be traced back into the kidneys, and it will complete the cycle of being absorbed, reabsorbed, going back to the intestine, getting reabsorbed, and going to the kidney, and from there also it is getting reabsorbed. Okay, so completely a complete water loss cannot be achieved. Okay, water is continuously either getting reabsorbed from your intestine, or the water is getting reabsorbed from the kidney. As I mentioned earlier, based on the level of your dehydration, the kidneys will decide, should we take up water back again, or should we let it go into in the form of urine. Okay. Next is your osmotic pressure. Is there any disturbance in the voice now? In a single phase, what do you mean by osmotic pressure? Is it from lower concentration to higher, or higher concentration to lower? It is higher to lower. Okay, it's not from lower to higher. It's a movement always from higher to lower. In the sense, just imagine, the best example is when you put raisins, dry raisins in water. Okay, they absorb the water after few time. Okay, why? Water concentration outside the raisins is higher. Inside the raisins, it is dry. There is no water concentration. Okay. So osmotic pressure means what? The movement of ions or water from higher concentration to lower. Okay. This because when there is an imbalance in terms of not just presence of water or absence of water, but also the presence of electrolytes or any other component. Okay. Osmotic pressure means where it is high, it will shift, it will send some of it to the lower concentration part so that a balance can be created. Okay, is it clear now? So yeah, water balance is also maintained by the osmotic pressure of your cells. Your cells already have semi-permeable membrane, your cell walls. Okay, in all the cells of your body, cell walls are semi-permeable membrane. This semi-permeable membrane of the cell wall will decide how much water should be retained inside the cell, that is intracellular fluid, and how much it should be outside the cell wall, that is outside the cell in the extracellular fluid. Okay, so as soon as the cells are getting dehydrated, fluid from the extracellular region will move inside the cell to create that equilibrium. Okay, and vice versa can also take place. If the extracellular fluid is getting dehydrated, fluid from the intracellular part can also, water can move from that area to extracellular part. Okay, so the osmotic pressure can work in both the ways. Wherever water concentration is high, okay, it is transported, it will move across the semi-permeable membrane to the regions where water concentration is low. So that's how natural osmotic pressure of different cell membranes in your body maintains the equilibrium of water balance in your body. Okay. Then we have edema. Edema means swelling. Okay. In edema, when you take a lot of salt, not just salt, anything that is rich in sodium. Okay, too much of sodium, if it is taken in excess in the form of any in food or solution or drinks or anything. Okay, too much of water will move into the interstitial place. Interstitial place means the area between the two cells. Okay, too much of water will move into the interstitial place because blood vessels, they have a limitation. Okay, definitely the blood volume increases, the cardiac output increases, but to protect the capacity of the blood vessels, these excess water from the blood, it will just cross over through the permeability of the blood vessels. The water will cross over to the interstitial place, and that's how you get edema, and that's how you get swelling. So swelling is basically the collection of fluid in the interstitial parts of your body. Okay, so that's how edema takes place. Edema is also happening to create an equilibrium so that your blood vessels are not harmed. Okay, your BP can be reduced to an extent so that cardiac output, the cardiac volume, blood volume is able to be reduced to an extent. It's not a solution. To an extent, if it can be reduced, it is well and good. Okay. So is it clear how water balance takes place within your body because of the natural mechanisms already inbuilt in your body? How your body becomes edematous to relieve the pressure of excessive blood volume on the vessels. How osmotic pressure is there to take water from higher concentration to lower concentration. How kidneys judge the amount of water or amount of dehydration in your body and help in reabsorption of water back into the system. And how thirst mechanism, you get thirsty, how the thirst mechanism happens. Dryness of the cells in your mouth and pharynx region, immediately thirst mechanism is triggered. You drink water. Okay. Is it clear about water balance? So next, dehydration. Dehydration is a condition characterized by water depletion in the body. It may be due to insufficient intake or excessive water loss, both. Either you are not drinking enough amount of water, or there will be, one second. Either you're not drinking enough amount of water, or you are drinking an amount of water, but there is an excessive water loss. And in some situations, both can happen. Okay. So excess of water depletion from the body is what we call as dehydration. That is the meaning of dehydration. So first type, due to the loss of water alone. It could be because of any traumatic injury, uh, diarrhea, constant vomiting, and any abuse of diuretics. These all will lead to excessive loss of water from the body. Okay. Next is the deprivation of water electrolytes. You are not drinking enough water. Okay. In terms of like drought prone areas, or you forget, or your thirst mechanism is impacted in children, in adolescents, teenagers. Okay. Yeah, they don't understand thirst. Usually kids don't understand thirst. They will keep on playing. They will keep ignoring that thirst. So that is deprivation of water electrolytes. Okay. In these two ways, dehydration can take place. So causes of dehydration: diarrhea, vomiting, excessive swelling, any adrenocortical dysfunction, that is your adrenal glands which are on top of the kidneys. If they have any dysfunction, they will not secrete the aldosterone, or even if the renin is being secreted by the kidneys, aldosterone will not be produced. Okay, so any dysfunction in the adrenal glands, okay, that could also lead to dehydration, because in that situation, without the presence of aldosterone, the kidneys will not know should we reabsorb the water or not. Okay, that is the main function of aldosterone, that it triggers the kidneys to help in the reabsorption of water. Water should not be completely lost in urine. It has to be taken up back into the system. But if aldosterone is only not present, water will be continuously lost through the urine without the knowledge that dehydration, the person is already dehydrated. Okay, so because of this adrenocortical dysfunction, dehydration can take place. Any kidney disease also can also lead to dehydration, and deficiency of ADH, aldosterone hormone. Okay, that could also lead to dehydration. Okay. So is it clear about dehydration? Similar content is given in the textbook also. You can just read about it. Next is water intoxication. That is the opposite of dehydration. Too much of water. Okay, too much of water. That is water intoxication, in which water concentration is too high in the body fluids. Cells will take in tremendous amounts of water, because every single system in your body is trying to create that equilibrium. Here, when there is too much of water, when you're consuming too much of water, your cells will try to help out because the body will definitely go into a state of edema. Interstitial spaces in the body is already filled up with water. Now the last resort is that cells have to take up excess water to find some space. Okay, so cells will take up all the excess water, how much ever is possible, and eventually it will burst. Cells will just swell up with water and it will eventually burst. It is a very fatal situation. It is a very fatal situation. Okay, so water intoxication is a very rare situation, usually when the thirst mechanism is impacted because of any traumatic head injury or any physical injury, because of which thirst mechanism, if it gets impacted, even if the person is not dehydrated, they will still feel thirsty. They will keep on drinking water. They become waterphilic in nature. They drink too much of water. They keep on drinking too much of water, and they become hydrophilic in nature, and they just want to the reason being that thirst mechanism is impacted. Usually it is because of any head injury, because the central nervous system, the area which controls the thirst mechanism, if it is injured, this kind of situation can arise. Okay, the patient will require medical attention, because if they continue it, the water to having too much of water, the body will go into a state of hyponatremia. Okay, so the electrolyte levels are normal. What you are getting from food or other fluids, your electrolyte levels are normal, but too much of water will keep diluting. The too much of water content in the body will keep diluting these electrolytes to an extent that body goes into a state of hyperkalemia, hypernatremia. Okay, so that is also fatal in nature. Okay. So these are the main electrolytes which is required by the body. Sodium we have discussed in detail just now. Chlorine, magnesium, calcium, and potassium. The balance between this electrolyte and water within your body leads to a state of health. Okay, these many electrolytes has to find a proper balance in your body. The presence of all these electrolytes will also maintain a proper blood pH levels as well, not too acidic, not too alkaline. Okay, the areas where sodium and potassium has to function indigenously, those areas will definitely be alkaline in nature. Other parts of the body has to be acidic in nature. Okay, they also carry electric signals from the nerves through muscles. Sodium, potassium, and chlorine, which we have discussed in the previous session, three of them were a major part in carrying electric transmission of from your nerve endings. Okay, so for your central nervous system also, these electrolytes are important. So that's about what electrolytes